Bunch of different form for quadratic equations. First, we have standard form of a quadratic, which is, very good, ax squared plus bx plus c equals 0, or y in general, correct? We have vertex form, which is f of x equals a parenthesis x minus h squared plus k. Note, standard form of a quadratic could be f of x as well. We also have factored form. Okay. Factored form, x minus r sub 1, x minus r sub 2 equals 0. The next, we have a really nice way of calculating, finding the coordinate of the vertex without using vertex form. Okay? Now, before we write what it is, let's go back to our example of y equals x squared minus 4x plus 4. And if we graph that, we would get that. How do I know that? Because that's, if we factor that, that would be x minus 2 squared. Does everyone agree with that? What multiplies to be 4 and adds to be negative 4? That'd be negative 2 and negative 2? So that'd be x minus 2 squared. Think about Spider-Man rules. What does that do to the graph? It moves it to the right 2. Now let's go and look at the discriminant of that. We're getting there. We're getting there. Okay, this is proving why it is what it is. The discriminant, remember, was a part of the quadratic formula. And based on the quadratic formula, or excuse me, based on the discriminant, it told us how many solutions there were to the number of solutions to the quadratic. Note, what coordinate is the solution in this case? It's 2, 0, and that's x-intercept. What is this coordinate of the quadratic? The vertex. Very good. So, let's figure out what happens here if we plug in b squared minus 4ac. You'll see where I'm going with this. Negative 4 squared minus 4 times a, which is 1, times c, which is 4, gives us 16 minus 16, which is 0, correct? Do you agree the discriminant equals 0? And the solution to this quadratic is what coordinate again of the parabola? The 2, 0. In general, it is the vertex, right? Think of the quadratic formula. X equals negative b all over 2a. Plus or minus all of this jazz over here, correct? Well, what is all of this jazz in this example? 0. Remember, b squared minus 4ac for this quadratic went to what? 0. Based on this information, all of this has gone to 0. We see that this calculates our x value of the vertex. Another way from standard form to calculate the x value of the vertex is simply negative b over 2a. That is how we, if we are in standard form right here, to figure out the vertex, the x value of the vertex, what do we simply do? Negative b over 2a. And then that will be the x value of the vertex. And then how do you find the y value? Plug the x value back in. So the coordinate of a vertex in general is negative b over 2a, comma, f. of negative b over 2a. The next they're looking at is next part is what is called projectile motion. When an object, and this is where we get into the first real important applications of quadratics, and this is a full unit that you do first semester physics, the first year. If an object is thrown in the air from the ground or in any sort of object, it could be dropped, but typically let's start with an object thrown from the ground at some velocity. As time goes on, what's going to happen to the object? It's going to go up, and then it's going to come down. And what we find is, you can go ahead and draw that, it follows the path of a parabola. It doesn't matter if it's a water droplet, it doesn't matter if it's a bowling ball, it doesn't matter if it's a baseball. All objects on the level of the real world that we're used to, not down at the quantum level, but at the real world objects we're used to seeing, they follow parabolas. At this point, we are just accepted that it does follow parabolas. It does, based on the law of physics and gravity. And when you get into the higher levels of the more mathematics of not just the position of the object, you'll start understanding why. If we have time, we'll talk about it. Okay? Now, we are still working with quadratics. But there is a specific form of quadratics in different variables that we are going to use for this in a second. You will not have to memorize this formula. S equals VT minus 16t squared. This will always be given to you. You will not have to memorize it. T is what? Time in seconds, typically. V is your initial velocity. When I throw the ball up in the air, I throw it at a specific velocity. If I put a lot of force behind it, what's going to be true about the velocity? It's going to be as great as I could have it. But as it initially leaves my hand, what's happening at every single point in time? Gravity is pulling down on it, and hence it's slowing down, and then gets to a high point, and instantaneously is at zero, and then it falls back to the ground. So that initial velocity only happens at the instant that the object is projected, whether it's someone throwing it or object fired, whatever it may be. S is your height at any point in time, lowercase s. Okay. Now, we have a bunch of different problems on the worksheet. I'm going to do specific examples, and then you have the ones after it. Not all the problems are going to have all of these parts, but I wanted to present all of this, and then we are going to problem solve in terms of which ones work for which. First off, example 1. I am doing example 1. They say use the vertex form, y equals ax minus h squared plus k. Instead of f of x, you can use y, that's fine. If we have a vertex 6, 1 and a point 0, negative 8. The vertex is 6, 1. What information is at a vertex form? hk. And then they give us a point 0, negative 8. Well, isn't that just our general x comma y coordinate, right? Right? X comma y is any point on the parabola. So we know 0, negative 8. So what are we plugging in for y? Negative 8. We don't know what a is. We know nothing about the condensing or expanding. X is what? 0. Remember, yes, we could plug 6, 1 in for x, y, but it's even more specific. It's the vertex, so we plug that in for h and k. Minus h, which is what? 6 squared plus k, which is 1. We really, probably be easier if we didn't have it in parentheses. When we solve for a, we get negative 1/4. After we have that, we rewrite f of x or y, I'm fine with either, negative 1/4 x in general, and then our vertex, minus 6 squared plus 1. First, they gave us h equals a half because the axis of symmetry in general is h. X equals h. Then they give us 2 points that it goes through. Do they tell us what, or excuse me, if either of those points are the vertex? Neither of those points are the vertex. Those are both x comma y. Does everyone agree with that? Yeah. So first, let's write out the form y equals a x minus h. Y equals a x minus h squared plus k. We know x, or h is going to be 1/2, correct? And for the first coordinate, what is the x value? 3/2, and that's being squared. We don't know what k is, we don't know what a is, but we do know what y is, which is what? 1. So, since we have 2 variables, we're going to need another equation. So how about we simplify this one? 1 equals, that would be 1 squared, that'd be 1 squared, so that's simply a plus k. Okay, now let's plug in the other coordinate. We have 2 comma 6, and again, we're plugging in h equals a half. I'll do this in a different color. Let's do this in red. Okay, so first, what are we plugging in for y? 6 equals, we don't know what a is, x equals 2, minus your h value, which is 1/2 squared plus k. After we plug in each square, so we get 6 equals, that would be 3/2, which is 9/4 a plus k. So when we look at these, we see that the coefficients of k are the same. So we're going to put one under the other and subtract them. So that'll eliminate the k's. 6 minus 1 gives us 5 equals 9/4 minus 4/4. That's 1 with the same denominator would give us what? 5/4 a, and that k term would go away. All right. Now we solve for a. Multiply by 4/5. Gotcha, yeah, okay. Now these cancel, and we have 20 over 5, or the 5's cancel, we have a equals 4. If we plug a back in, we get k, and either of the equations, we get k equal to -3. In the interest of time, we're not going to, but you rewrite with a, h, and k plugged in. That right there is in factored form. And because it's minus, if we set that equal to 0, our r sub 1 and r sub 2 would be our roots, correct? But in this case, it's not r sub 1 and r sub 2. What is it? P and q. Just p and q, right? Okay? So once again, they'll write it in a certain way using different variables. This is in factored form. If we use a zero product property, set it equal to 0, we in general get p and q as our 2 roots. Questions? Okay? Now we look over here. They say write the values of p and q. So what are they asking us to find? The values of p and q. And what are p and q again? They are the roots or the x-intercepts. What's our first one? They're simply x-intercepts, which is the same as roots, correct? So what is p going to be? Our first one, which is -1/2. And q is going to be our second, which is what? 2. They give it, we have factored form, and we want to get into standard form. So let's set it up. Y equals x minus -1/2 is the same as +1/2, and then x minus 2. Now, this looks like MAF. We have to FOIL this out to get in standard form. What do you think we can do with this, too, to make it nice and easier for ourselves? Move it out front. Very good. Just like we do with MAF. If we put it in this form, we now can FOIL. We get 2x squared minus 4x plus x minus 2 and then we combine to get 2x squared minus 3x minus 2. Vertex. So now we find the vertex. X equals negative b over 2a. X equals the opposite of 3 in the numerator, gives us simply 3, correct? And then you plug 2 in for the denominator, which gives us the x value of 3/4. We're not going to do it, but to find y, plug in 3/4. Number 9 is your form here. Note this should have been 80t minus 16t squared. You want to first find out if a ball is thrown with initial velocity, how long will it take to get its highest point? We do vertex form, negative b over 2a. What is b in this case? 80. So you do negative 80 over 2 times a, which is negative 16. And that's going to give us, I believe, 2.5.
Yeah.
That's letter A. That's how long it'll take to get its highest point. How high will it go? We simply plug the time back in and then calculate. And you can use your calculator for that, as that will be on the calculator portion.